Hello students, today we are going to see about the continuation of the LCM tricks which I posted in the previous video here. So here we will move on to the LCM, finding the LCM of the larger numbers. Here we are going to take three numbers, that is 13, 26 and 39. I'm going to use the LCM trick to do it. So in the previous video, if you look into it, I would have explained about the detail about these steps and the few examples. Please watch the video, then come back to this video, then you will have a better clarity on this. So now I have to choose the bigger number here, that is 39. Have to check whether 39 is present in 13 table as well as in 26 table. 39 is present in 13 table but not in 26 table. So now I'll start writing the multiples of 39. When I start writing the multiples of 39, 39 ones are 39, which already checked, which is not present in 26 table. Now I'll move on to 39 into 2. I'll be getting here 78. Now I have to check whether the 78 is present in 13 table as well as in 26 table. So I will come to conclusion that it is present in 39 table. Now I have to check out whether it is present in 26 table. So you may wonder how I'm directly telling that 78 is present in 13 table. I have also posted a video regarding the 13 table tricks using the table format. Please check out the video so you will have a better understanding. So how to remember 13 table easily here. Okay. So now here we will check out whether it is present in 26 table. Definitely it is present in 26 table, that is 26 into 3s are, I'm getting here 78, as well as it is present in 13 table, that is 13 into 6 are, which is 78. It is present both in 13 table as well as 26 table. Then now I can come to the conclusion that LCM of 13, 26 and 39, which is 78. Without doing any prime factorization, we are able to find out quickly. Now let's move on to the next problem. The second problem, we are going to find out the LCM of four numbers. The four numbers which I have taken here, it is 12, 24, 36 and 48. So here I have to choose the bigger number. The bigger number is 48. I have to keep checking this 48 is present in 12 table. It is present in 12 table. I have to check whether it is present in 24 table. It is also present in 24 table, but it is not present in 36 table. So I cannot conclude that LCM is 48. Now I have to start writing the multiples of 48. So we get 48 into 1s are, I will be getting here 48. Then 48 into 2s are, I'll be getting here 96. So now I have to check whether 96 is present in all the three tables. It isn't present in 12 table or 24 table as well as in 36 table. It is present in 12 table. It is present in 24 table as well as it is not present in 36 table. It is not present here. Now I have to move on to the next number, that is 48 into 3. So 48 into 3, which is 144. I have to check whether this 144 is present in 12 table, 24 table as well as in 36 table. That is my priority of checking. So in 12 table is definitely it is present because 12 12s are 144 I'll be getting here. So now I have to check whether it is present in 24 table. So you need not write, keep on writing the full 24 table. See, when you look out here, here is ending with 4. So when I do here 24 into 4s are, I can try. When I try 24 into 4s are, 4 4s are 16, then 1, I'll be getting here 96. So which is not 144. So then where I will get 4 at the ending, I have to check out here. So next if I do here 24 into 6, why 6 4s are 24, it is ending with 4, right? So therefore I will do it with this to get it out, check it here. So now you understood what the way I am doing here to check it. So 24 into 6 are 6 4s are 24, 4 and 2, then 12, 14. I'm getting here 144. So here the ending number is 6, so therefore it won't come. Here the ending number is 4, and also I'm completely checking by multiplying 24 into 6. Therefore I am getting here 144. It is present in 24 table, is present in 12 table. Now my priority is to check in 36 table. So when I check in 36 table, if I do here, I must get 4 at the last. So if I check here 36 into 4, so I will be getting here 4 at the last, then to carry over if I do 12, then for 144. I'm getting here 24 into 6 are I'm getting 144, and 36 into 4s are 144, and 12s are 144. Now I can come to the conclusion that my LCM of 12, 24, 36, 48 is 144. See now how we got it in a very easier manner without doing any prime factorization. Now let's check on to the one more number. So hope you will be able to understand very much clearly. So now we are going to see about the LCM of 2, 4, 6, 8, 10, 12. You may wonder, so how can I do without prime factorization using each and every table? So similarly, first check out the largest number, that is 12. So once you check out the largest number 12, you have to check whether the 12 is present in 2 table. Definitely is present in 2 table. It is present in 4 table. It is present in 6 table, but not in 8 table. It is present not in 10 table also. So now what I will do, I will have to check the multiples of 12. When I check the multiples of 12, so when you keep on checking 12 twos are 24, then again it won't be there in few tables. It will be there in 2, 4, 6, 8, but not in 10. So when you check here, till 12 tens are, no number will appear in the 10 table. So directly you can move here, 12 tens are 120. When you do 12 tens are 120, this 120 will present in 2 table, 4 table, 6 table, 8 table, as well as in 10 table it will be present there. So now I can conclude that the LCM of 2, 4, 6, 8, 10 and 12, which is 120. So now it is very easily you can find out this multiples here. So now let's move on to the next problem. So now here we are going to check the LCM of 15, 25, 40 and 75. Here also the first step what I'm going to do, I'm going to choose the biggest number. The biggest number is 75. Have to check whether it is present in 15 table, 25 table as well as in 40 table. I have to check out here. So when I check out here this 15 table, it is present. It is present in 25 table also is present, but in 40 table it is not present. So when you check out here in 40 table, definitely it should end with 0. So such a way that only you have to take a multiples of 75. When you take multiples of 75 where you are getting 0, you have to check out clearly, you have to do it in that manner. So when you do here, if I'm doing here 75 into 4, I will be getting here what? 300. So this 300 I have to check whether it is present in 15 table, 25 table as well as in 40 table. I have to check here. So if I do it in 15 table, definitely it will be present here because 15 into 2 which is 30. Here 15 into 20 you will be getting here it is 300. So now I have to check whether this 300 is present in the 25 table. Already we have seen the divisibility rule of 25. So when you check out the divisibility rules video, you will understand why 300 is divisible by 25. So now I have to check whether 300 is divisible by 40 or not. I have to check here. So when I'm checking here, it won't be divisible by 40. Why it won't divisible by 40? As usual, we know divisibility rule of 4, it should be end with 2 zeros. By 40, there should be one more zero should be there. So therefore, I can conclude that it is not divisible by 40. So next I will move on to the here where I am getting here 0. I have to check here. So if I do 75 5s are, it will be ending with 5. If I'm doing here 75 6 are, it won't be ending with the zeros or anywhere. So now it is, I can move to the 75 8s are. Why I am directly moving to 75 8s are? 8 5s are 40. So 0 you will be getting here, right? So definitely you can try 75 into 8. 75 into 8 you will be getting here 600 you will be getting here. When you check it here, this 600 it should be divisible by the 15 table. When you check here, definitely it will be here. I know 15 into 4 which is here 60. Now 15 into 40 that will be here 600. Definitely it is present here. As usual the divisibility rule of 25, 600 is divisible by 25. It is present in 25 table. So now I can come to the conclusion that it is present in 15 and 25. Now I have to check whether it is present in 40 table or not. So 40 table, now only we saw here 40, 15 into 40 is 600. Similarly, 40 into 15 also it is 600. 15 to 40 and 14 to 15 both means the same. So it is now 600 is present in 15 table, 25 table and 40 table. Now I can come to the conclusion that LCM of 15, 25, 40 and 75, which is 600. So now hope you understood very much clearly. Now we will see very last problem with few numbers to make you very much clearly here. Now we are going to find the LCM of 1, 2, 4, 5, 10, 20. So now I'm going to come to the conclusion that the LCM of these numbers is 20. Why I'm selling here? It is present in 1 table, 2 table, 4 table, 5 table, 10 table. So directly LCM is 20. So now hope you have a very clear explanation for these 5 problems. Please keep on doing more numbers by yourself. Therefore, you will be able to crack the LCM in the rapid speed. Okay, keep practicing. If you have any doubts in any such problems for any such numbers, if you're not getting, please post me in the comments so that I can help you on that. Thank you, friends. Have a great day.